Welcome to Digital Learning, Department of Collegiate Education. I am Dr. Vanaja V, Assistant Professor, Department of Mathematics. In this video, let us learn the chapter Integral Calculus, which is prescribed for first semester BSc Mathematics Paper 1. Under this chapter, we are going to learn reduction formulae. But particularly in this video, we are going to understand the term of reduction formula for integral sine to the power nx into dx and integral cos to the power n of x into dx. Learning objectives are to understand the concept of reduction formula, to derive the reduction formula for integral sine to the power n of x dx and integral cos to the power n of x dx, and also for definite integrals of the same functions. To apply these to evaluate given integrals. The learning outcomes are to able to understand the concept of reduction formula, to able to derive the reduction formula for integral sine to the power n of x dx and integral cos to the power n of x dx, and also for definite integrals of same functions. Able to apply these to evaluate given integrals. Prerequisites: list of integral formulae, methods of integration, properties of definite integrals. The meaning of reduction formulae: a formula which expresses the given integral in terms of another which is simpler in form is called the reduction formula of the given integral. The successive application of this reduction formula enables one to express the given integral in its simplest form. These formulae are generally obtained by applying the rule of integration by parts. For example, the simple form of integral of sine of x dx easily we can write, which is equal to minus cos x. Suppose if we are having integral of sine to the power 2 of x dx, we are not having a direct formula for this. So for that we have to use the term, that is sine square of x can be written as 1 minus cos 2x whole divided by 2. So to integrate that one, we are using the same particular formula. That is integral of sine square x dx equals to integral of 1 minus cos 2x whole divided by 2 into dx, which is equal to half into x minus sine 2x divided by 2, which is little bit tedious form. So to get the easiest simpler formula, we are having the reduction formula for integral of sine to the power n x into dx. Let us learn how to get the reduction formula for integral of sine to the power n of x into dx in the next slide. Okay, see, there's a caption is given like this way: reduction formula for integral of sine to the power n of x dx, where n is a positive integer. Let us consider in equals to integral of sine to the power n of x into dx. Let it be equation 1. In this case, n is a positive integer. So we can rewrite this n to the power sine to the power n of x in terms of sine to the power n minus 1 of x into sine of x in two terms, product of two terms. If the bases are same, we can add the power, so we'll get back the same term, that is sine to the power n of x. Here if I'll consider sine to the power n minus 1 of x as a first function and sine of x as a second function, and we can use the method of integration by parts. The method of integration by parts is given by integral of u into v into dx can be written as u into integral of v dx minus integral of v dx into derivative of u dx. In this particular term, u can be considered as sine to the power n minus 1 of x, v can be considered as sine of x. So the first function u we can rewrite as it is sine of n minus 1 of x into the second function v, that is integral of sine x, is nothing but minus cos of x minus integral of the derivative of the first function. The derivative of the first function is n minus 1 of sine to the power n minus 2 of x into the derivative of sine is cos, that is a cos x. Then the integral of the second function, that is sine x, can be taken as minus cos x into dx. After simplifying all these things, we can rewrite this expression in this format, that is minus sine to the power n minus 1 of x into cos x plus, because we got plus here, minus into minus, and here n minus 1 we can take it outside of this integral sign, and sine of n minus 2 of x into cos cos square x into dx. Here we can use the identity term, that is cos square x plus sine square x equals to 1. So cos square x can be written as 1 minus sine square of x. And again here we are having minus, so again we can rewrite in this form, minus sine to the power n minus 1 of x into cos of x plus n minus 1 of integral sine to the power n minus 1 of x into 1 dx, we can write as one term, and minus sine to the power n minus 2 of x into sine square of x can be taken as sine to the power n of x into dx. That we can observe in this next expression. And already we have considered in equals to integral of sine to the power n of x into dx. So similarly, n minus 2 equals to integral of sine to the power n minus 2 of x into dx. So that I can use it in this expression. The first part can be written as minus sine to the power n minus 1 of x into cos x plus n minus 1 into integral of sine to the power n minus 2 of x dx can be written as in minus 2, and minus of n minus 1 of integral of sine to the power n of x dx can be written as in. And in the LHS I consider that is nothing but in, and in the RHS the last part I am having minus n minus 1 of in. Just transpose this minus n minus 1 of in to the RHS side. So we can rewrite this expression in this form, in plus n minus 1 of in, which is equal to minus sine to the power n minus 1 of x into cos of x plus n minus 1 of in minus 2. If I simplify this one, we can get in plus n into in minus in. In get cancels, and we left with the term n into in. We can transpose this, the coefficient n, to the denominator of the RHS side. That we can rewrite in equals to minus sine to the power n minus 1 of x into cos x whole divided by n plus n minus 1 divided by n into in minus 2, which is the reduction formula for the given integral, that is in equals to integral sine to the power n of x into dx. So to evaluate our definite integral for the same function, same integrand, that is integral 0 to pi by 2 sine to the power n of x into dx. Consider in equals to integral 0 to pi by 2 sine of n of x into dx, which is a definite integral, and already we have got the reduction formula for an indefinite integral, that is in equals to integral sine to the power n of x into dx. Same thing we can rewrite using the formula 2. In equals to minus sine to the power n minus 1 of x into cos x whole divided by n. The limit moves from 0 to pi by 2. Here this first part is already integrated completely, plus the second part of that expression, that is n minus 1 divided by n into in minus 2. Here in minus 2 is nothing but integral of sine to the power n minus 2 of x dx, which is not integrated, so I never applied the inner limits to this complete function. For the first function we can apply the limits. So before applying the limit, let us evaluate the terms. That is, cos of pi by 2 is nothing but 0. Sine of 0 is equal to 0. Therefore, we already know that one. We can apply the upper limit first minus lower limit. If I'll apply the upper limit, that is sine of n minus 1 of pi by 2 into cos of pi by 2. Already we know the value of cos of pi by 2, that leads to 0. The first term get cancels. Minus second term sine of 0 into cos of 0. So cos of 0 is 1 but sine of 0 is 0. 0 into any function, again it leads to 0. Therefore, the complete first function vanishes or it leads to 0. And we'll get back the term in equals to n minus 1 whole divided by n into in minus 2, which is the reduction formula for the term integral 0 to pi by 2 sine to the power n of x into dx. But here we left with another integral term, that is in minus 2. To remove this one, we have to produce the terms, or we have to change the terms, that is n in the place of n minus 2. That's the thing here I have given. Now change n to n minus 2 in equation 4. Therefore equation 4 becomes n minus 2 equals to n minus 2 minus 1 whole divided by n minus 2 into n minus 4, which is equal to n minus 3 divided by n minus 2 into in minus 4. Now we have to get the value for in minus 4. So for that sake, what we can do means change n to n minus 4 in equation 4. So we'll get in minus 4 equals to n minus 4 minus 1 whole divided by n minus 4 into in minus 6. So after simplification, we get n minus 5 whole divided by n minus 4 into in minus 6. Now to get the value of n minus 6, again we can change n to n minus 6 in equation 4. Again it yields the result as in minus 6 equals to n minus 6 minus 1 whole divided by n minus 6 into n minus 8, which is equal to n minus 7 divided by n minus 6 into n minus 8. So let us consider this equation 5. Proceeding like this, we end up with the result I3 and I3 and I2. So I3 can be written as 2 by 3 of I1 when n is odd. The result I2 equals to 1 by 2 I0 when n is even. Thus, using 5 in 4 we work time. That is, we are having the expression 4 expression in equals to n minus 1 divided by n into in minus 2. Replace the value of in minus 2. In minus 2 we got n minus 3 divided by n minus 2 into in minus 4. Now replace the value of n minus 4 as n minus 5 divided by n minus 4 into in minus 6. We can continue this one till to get n is odd or a even. So here I have given like this way, in equals to n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 till it will continues and it will end up with 2 by 3 into I1 when n is a odd number. N minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 continues and it end up with 1 by 2 I0 when n is an even number. So then we have to find out the term of I1 and I0. If I'll consider here I1 equals to integral 0 to pi by 2 sine to the power 1 of x into dx. Already we know that integral of sine x is equal to minus cos x. Apply the limits, that is 0 to pi by 2. The first function, that is cos of pi by 2, is 0. Minus into minus it becomes plus. Cos of 0 is 1. So I1 leads the result always, which is equal to 1. The I naught equals to integral 0 to pi by 2 sine to the power 0 of x into dx. Any number to the power 0 is 1. So we'll get here 0 to pi by 2 into dx. The integral of dx equals to x, and apply the limit 0 to pi by 2, which is the result in the form of pi by 2. Therefore, the expression or the integral in equals to integral 0 to pi by 2 sine to the power n of x dx, which can be written as n minus 1, n minus 3, n minus 4, 5 up to 2 whole divided by n into n minus 2, n minus 4, and it leads to the last term as 3 when n is odd. The same term repeats for when n is even, but it leads the result as pi by 2. We have to multiply pi by 2 at the end. So that we can also rewrite in this form. In equals to integral 0 to pi by 2 sine to the power n of x into dx equals to n minus 1 into n minus 3 into n minus 5 whole divided by n into n minus 2, n minus 4 up to the term we can consider k. If n is an odd number, k yields as the result 1. If n is an even number, then k becomes pi by 2. And here we are having all the multiples. If n is an even number, multiply at the end 1. Sorry, even means it is multiply at the end pi by 2. If it is odd, multiply at the end k equals to 1. So next we are moved to another term or another reduction formula for integral cos to the power n of x into dx, where n is a positive integer. Same methodology we can apply here to get the reduction formula for integral cos to the power n x into dx. So let in equals to integral cos to the power n of x into dx, that is 1, where n is a positive integer, and this we can cos to the power n of x into n of x can be written as cos to the power n minus 1 of x into cos of x dx. Here we are having two functions. Using the method of integration by parts, we can write here in equals to first function cos to the power n minus 1 of x into cos of x minus integral, the derivative of the first function we can write n minus 1 into cos to the power n minus 2 of x. The derivative of cos is minus sine of x, and the integral of cos x is sine x into dx. The same thing we can rewrite here, cos to the power n minus 1 of x into cos x. Here I am having minus into minus, it becomes plus, and n minus 1 is a constant term we can take outside of the integral. So then integral cos to the power n minus 2 of x into sine square of x into dx. Using the identity that sine square of x can be written as 1 minus cos square of x into dx, and multiply this cos square n minus 2 of x into 1 minus cos square of x into dx, we'll get the expression in this form, that is cos to the power n minus 1 of x into sine of x plus n minus 1 into integral cos to the power n minus 2 of x into dx minus n minus 1 integral cos to the power n of x into dx. As we have considered that in equals to integral cos to the power n of x into dx, so we can rewrite that n minus 2 can be considered as integral cos to the power n minus 2 of x into dx. So here in can be written as cos to the power n minus 1 of x into sin x plus n minus 1. This integral part we can rewrite as in minus 2 minus n minus 1. This integral part can be denoted as in, and transpose this complete term to RHS and simplify. It yields in equals to cos to the power n minus 1 of x into sin x whole divided by n plus n minus 1 whole divided by n in minus 2 This is the reduction formula for integral cos to the power n of x into dx. Once again, just we can observe this formula, that is in equals to integral cos to the power n of x dx, which is equal to, the reduction formula is given here, that is cos to the power n minus 1 of x into sin x whole divided by n plus n minus 1 divided by n into in minus 2. So again we can evaluate the definite integral for this cos to the power n of x into dx. That is, to evaluate integral 0 to pi by 2 cos to the power n of x dx. Let in equals to 0 to integral 0 to pi by 2 cos to the power n of x into dx. As we know the reduction formula for the integral cos to the power n of x dx, same thing we can use it here. That is in equals to integral cos to the power n minus 1 of x sin of x whole divided by n integral 0 to pi by 2, which is already integrated completely. But here in minus 2, which is nothing but an integral 0 to pi by 2 cos to the power n minus 2 of x into dx. Here we can apply the upper limit and lower limit. As we discussed earlier, cos pi by 2 is 0, sin pi by 2 is 1, but cos 0 is 1, sin 0 is 0. Again, if I'll apply upper limit as well as lower limit, the first term completely gets 0. So we left with the term in equals to n minus 1 divided by n into in minus 2. So for the successive progressive terms of the using the reduction formula, we can get this in minus 2 value that yields the term as in minus 4, again in minus 6, again in minus 8. It continues. That I have given here, that is to get the reduction formula for in for the equation 3, we are using equation 4 here. In this equation 4, to evaluate the term in minus 2, we have to change here n by n minus 2. If I'll change that n by n minus 2, we'll get here, in the place of n, I can just substitute n minus 2. In minus 2 equals to n minus 2 minus 1 whole divided by n minus 2 in minus 4, I'll get it, which is equal to n minus 3 whole divided by n minus 2 into in minus 4. Similarly, to get the value of in minus 4, change n by n minus 4 in equation 4, it yields the result, that is in minus 4 equals to in minus 4 minus 1 whole divided by n minus 4 in minus 6, which is equal to n minus 5 whole divided by n minus 4 into in minus 6. So proceeding like this way, we end up with the result I3 as well as I2. I3 in terms of I1 and I2 in terms of I0. As we already know the term of I1, here I1 is integral cos x dx with the limit 0 to pi by 2, and I0 is nothing but integral 0 to pi by 2 into dx. So say if I'll substitute all the values in equation 4, I'll get in equals to n minus 1 divided by n into in minus 2. This we can write in minus 2 can be taken as n minus 3 whole divided by n minus 2 into in minus 4. In minus 4, again we can write n minus 5 divided by n minus 4 into in minus 6. Again we can write the in minus 6 values. If I'll continue the terms, it is the result in equals to n minus 1 divided by n into n minus 3 divided by n minus 2 into n minus 5 divided by n minus 4 up to I1 when n is odd, up to I0 when n is even. So find out the value of I1 and I0 and multiply those terms for if n is even I1 we have to multiply. If n is odd, multiply I0 value. That is, for I1, that we can also consider here I1 is an odd term. It leads to 1 because integral of 0 to pi by 2 cos of x dx is nothing but the sine of integral 0 to pi by 2. The sine pi by 2 value is 1. So if I'll substitute the upper limit, I'll get sine pi by 2 minus sine 0. Sine pi by 2 is 1, sine 0 is 0. So it is the value 1. For an even number, that is I0, integral 0 to pi by 2 dx will get it, that is equal to x integral 0 to pi by 2, that will get the result as pi by 2. So which is a simpler formula for both the terms of sine as well as cos to the power n of x into dx. Once again, the reduction formula for integral 0 to pi by 2 sine to the power n of x into dx, which is equal to integral 0 to pi by 2 cos to the power n of x into dx, which we can also rewrite in this format, that is n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 up to the term k. Here we have to consider n as well as k. If n is odd, k becomes 1. If n is even number, k becomes pi by 2. Same thing I have explained here. So based on these formulas, reduction formulas, let us learn or understand some of the problems. See here, the first problem here I have considered, evaluate integral sine to the power of 6x into dx. We know that In equals to integral sine to the power n of x into dx, which is equal to minus sine to the power n minus 1 of x into cos of x whole divided by n plus n minus 1 whole divided by n in minus 2. Here the n is given as 6, so I can consider I6 equals to integral sine to the power 6 of x into dx. In the place of n, just substitute 6. So minus as it is, sine to the power 6 minus 1 is 5 of x into cos of x whole divided by 6 plus and 6 minus 1 is 5 divided by 6 into I4. So replace this one as it is plus 5 by 6 as it is, here I4. Again in the place of In, the formula, just substitute I4. So that again I'll get here minus sine to the power 4 minus 1 is 3 of x into cos x whole divided by 4, n is 4 here, plus 4 minus 1 is 3 divided by 4 is n is 4 into I2. Again, just this particular first term we can keep as it is, and the second term we can multiply with this complete term. So that is plus into minus minus 5, 6 into 4 is 24 into sine to the power 3 of x into cos x, then plus into plus plus. Again we are having here, you can simplify here, 3 ones are 3 twos are 6, so 5 divided by 8 I2. So in the first term I can replace as it is, second term I can replace as it is, but the third term I am having here 5 by 8 into I2. Again in the place of In I can substitute I2. So there what I'll get it means 5 by 8 minus sine to the power 2 minus 1 is 1 cos of x whole divided by 2 plus, again I'm having n is here 2, 2 minus 1 is 1 divided by n is 2, 2 half, again I0. Again I0 equals to, here if I substitute I0 means sine to the power 0x is 1x. Integral of 1x dx is x. So I can just replace that x here. So for that, replace the first one as it is. second term as it is. Say the third term, here I am having plus into minus minus 5, 8 2s are 16, sine of x, cos of x, again plus 5 1s are 5, 8 2s are 16, I naught can be considered as x. And this is the complete answer for this. To get the more clear simplified form, take the LCM and get this result. And the second form problem here we have considered with the definite integral 0 to pi by 2 sine to the power 5 of x into dx. So by the reduction formula, In equals to integral 0 to pi by 2 sine to the power n of x dx, which can be considered as n minus 1 by n into n minus 3 by n minus 2, n minus 5 by n minus 4 up to k. We can consider. Here, the given n is equals to 5. 5 is an odd number, so k can be considered as 1. That's why here I consider it is equal to 1. So therefore, I5 equals to integral 0 to pi by 2 sine to the power 5 of x into dx, which is equal to 5 minus 1 is 4, then 5 minus 3 is 2, then 5 minus 5 it leads to 0, so that we won't take, we'll consider the lesser term only. So I can consider here only two terms, that is 5 minus 1 is 4 in the numerator, 5 minus 3 is nothing but 2 in the numerator divided by, in the denominator I am having n is 5, second term is n minus 2, that is 5 minus 2 is 3. And I got here the last term has 2 by 3. So if we want, we can multiply 1 or we can leave it k as 1. And just simplify this one. 4 2s are 8 and 5 3s are 15. This is the result for the given problem. Here's the third one, the same problem. Evaluate integral 0 to pi by 2 sine to the power 4 of x dx. In the previous problem, we have considered n equal to 3, that is an odd number. Here we can consider the even number. See, here we are having IN formula. IN formula is same thing, but once it is an even number, we are having as a power number. At the end, we have to multiply pi by 2. In this case, n equals to 4. So, k equals to pi by 2 I can consider. In equals to integral 0 to pi by 2 sine to the power 4 of x dx, which is equal to 4 minus 1 is 3 divided by 4 into 4 minus 3 is 1 divided by 4 minus 2 is 2 into pi by 2. Simplify. We get a result 3 into pi divided by 8. See again here we have considered the cos term. That is fourth problem. Evaluate integral cos to the power 7x into dx. By reduction formula we have In equals to integral cos to the power n of x dx equals to cos to the power n minus 1 of x into sin x whole divided by n plus n minus 1 divided by n into In minus 2. In this case, n equals to 7. So, if you want, we can consider here integral cos to the power 7 of x dx equals to cos to the power n minus 1, that is 7 minus 1 is 6 of x into sin of x divided by 7 plus 6 by 7 into I5. Again, in this expression, we can just take in the place of n 5 for the next step. So that one, we can replace the first one as it is. Second one, 6 by 7, your 5 is there. So therefore, cos 5 minus 1 is 4 of x plus sin of x divided by n5 plus 4 by 5 into I3. Again, multiply this 6 by 7 with these two terms and which yields in this format. Again, it leads to the term I3. Again, in the place of n in the equation first, reduction formula, just use the term n is equal to 3. So, the first term as it is, second term as it is. The third term, the coefficient 24 by 35 we can replace as it is. And here I3 can be written as cos 3 minus 1 can be taken as cos square of x into sin x whole divided by 3 plus 2 by 3 into I1. So here the first term replaced as it is, second term replaced as it is, third term for the first term multiply, and you can simplify that one. Here 3 ones are 3 eights are 8 by 35 cos square of x into sin of x plus, here we are having, after simplification we get 16 by 35 into integral of, because here I1 is nothing but cos of x into dx, integral of cos x. The integral of cos x is nothing but sin x, and replacing all these things and taking the LCM. Here the LCM is 35, so we can write it 1 by 35 into sin of x, you can take out as a common. We will yield a result in this form, 5 times of cos to the power 6 of x plus 6 times of cos to the power 4 of x plus 8 times of cos to the power 2 of x plus 16. Here I have considered another problem, that is evaluate integral 0 to pi by 2 cos to the power 8 of x into dx. Again, it is a definite integral formula. As we are aware of the term, the sine to the power for a definite integral 0 to pi by 2 sine to the power n of x dx, which is equal to integral 0 to pi by 2 cos to the power n of x dx. And if it is n is an even, k we can consider as pi by 2. If n is an odd number, k can be considered as 1. Here it is given as a even number, n is equal to 8. At the end we have to multiply pi by 2. So here 8 we can write, that is 8 minus 1 is 7 by 8. Then 8 minus 3 is 5 by 8 minus 2 is 6. Then 8 minus 5 is 3 by 8 minus 4 is 4. Again 8 minus 7 is 1 by 8 minus 6 is 2. And at the end if it is 1 by 2, then also we can just multiply pi by 2. After simplification, it yields the term as 35 into pi divided by 256. So again here I consider one more problem, that is evaluate integral 0 to pi by 2 cos to the power 3 of x into dx. Here n is an even number, at the end we can multiply 1, and we are having the reduction formula here, in equals to integral 0 to pi by 2 cos to the power n of x into dx, which is equal to n minus 1 into n minus 3 into n minus 4, 5 etc. whole divided by n into n minus 2, n minus 4 into etc. we can add. Here n is equal to 3, so we can write I3 equals to integral 0 to pi by 2 cos to the power 3 of x into dx equals to n minus 1 is 2 divided by n is 3. The result is 2 by 3. So we can learn many such problems in different books, and we can also just go through these other reference books. That is, one is the Shanti Narayan and P.K. Mittal Integral Calculus, S. Chand and Corporate Company Private Limited, and N.P. Bali Integral Calculus, India Lakshmi Publications, and G.K. Ranganath BSc Mathematics for first semester, and G.P. Gururajachar Mathematics BSc first semester. So we can just get the different problems and different results. We can get it in these books, and also we can refer different books also. So thank you.